Chapter 7, Section 5, Logistic Growth. This is the last section of Chapter 7. On page 373, Exercise 6. It's the integral of 2x plus 16 over x squared plus x minus 6 dx. We're going to find this integral using partial fraction decomposition. Sometimes we just say partial fractions for short. In the video called Partial Fraction Decomposition, we did a few minutes of algebra to turn this fraction into negative 2 over x plus 3 plus 4 over x minus 2. So, like I said, it takes a few minutes to decompose this fraction into the sum of these two fractions. So check out the video called Partial Fraction Decomposition. Then we're going to distribute this integral sign. Negative 2 integral 1 over x plus 3 dx plus 4 integral 1 over x minus 2 dx. So this first term is negative 2 times 1 over x plus 3, which is the first fraction here. The second is positive 4 times 1 over x minus 2. That's the second fraction. And this becomes negative 2. The integral of 1 over x plus 3 dx is the natural log of the absolute value of x plus 3. In my head, I said let u equal x plus 3. Then du is 1 dx. So in my head, I see this as the integral of 1 over u du. 1 over u du. The integral of 1 over u du is the natural log of the absolute value of u. This integral is the same type. It's the integral of 1 over u du. This is u, and this is du. The integral of 1 over u du is the natural log of the absolute value of u plus c. And we're done. That's it. Other ways this could be written. You could write the positive term first. Positive 4 natural log absolute value of x minus 2 minus 2 natural log absolute value of x plus 3 plus c, and a number in front of log can be brought up here is the exponent. Same with this 2, it's a number in front of log, so the 2 instead of here can be written here, and a log minus a log can be written as 1 log of the quotient like that. And the answer key has the absolute value signs gone, because if you raise something to the 4th power, anything to the 4th power, it will be positive. Same with the exponent 2. Anything raised to the second power will be positive. So I check the answer key for this, and it says the natural log of x minus 2 to the fourth over x plus 3 squared plus c. But we actually had the correct answer here. There's nothing wrong with this answer. We just rewrote it a few times. And the next one is number 10. Actually, I'd prefer to do number 12 next. We'll do 10 after we do 12. Number 12 is the integral of 1 minus 3x over 3x squared minus 5x plus 2 dx. You watch the video called partial fraction decomposition to turn this fraction into 3 over 3x minus 2 plus negative 2 over x minus 1. It takes a few minutes to turn this fraction into the sum of these two fractions. Partial fraction decomposition. Then we distribute the integral symbol. The integral of the first term, the 3 in the numerator can be brought out here, times 1 over 3x minus 2 dx distributes, plus a negative. We can just write negative integral 2 to the left of the integral symbol, 1 over x minus 1 dx. For the first integral, if we look over here, if we let u equal 3x minus 2, then du will be 3 dx, which means you can bring this 3 back over here if you want, or make the 3 that you wish was here, just make it appear, abracadabra, then put 1/3 out here. However you look at it, this is going to be 1 integral du over u. Since this is du, and this is u. This is already in the du over u form. No need for any magic chalk. The integral of 1 over x minus 1 dx is the natural log of the absolute value of x minus 1. Because I'm thinking of making the denominator u, and then du would be 1 dx, which is what's there. Okay, so no number in front there anymore. This is just the natural log of the absolute value of u, which was 3x minus 2 in that case, minus 2 natural log absolute value of x minus 1 plus c. And I'll call this the answer, and I'll just tell you what the book's answer is, and you can verify in your own mind if this is the same. Book says the answer is the natural log of the absolute value of 3x minus 2 over parentheses x minus 1 squared. That's textbook's answer. Are these the same? Now, number 10. The integral of 3 dx over x squared plus 9. 3 comes to the left of the integral symbol. This denominator we can't factor. And this is actually just a direct use of one of the basic integral formulas. One of the basic integral formulas on your sheets. You have a couple of sheets with formulas. One of them is the integral of du over a squared plus u squared equals 1 over a arctan u over a plus c. This is the basic. Dx du, a squared is 9, x squared is u squared. That 3 just comes down, and this integral is 1 over a, that number is a squared, arc tan u over a, that's u squared, meaning u is x, over a is 3, because this is a squared, plus c. So no partial fraction decomposition, straightforward formula. 3 times 1/3 is 1, so the answer is arctan x over 3 plus c. Right, so the title of this section is Logistic Growth. Exercise 28 says dp dt equals 0.008 p times 700 minus p. And when a differential equation has this form, when I say this form, I mean this, which is on a handout you have. The differential equation has the form dp dt equals kp parentheses m minus p. This is what we mean by logistic growth. It means this differential equation. In this example, k is 0.008. Actually, I think there's a third zero in there after the decimal point. N is 700. The solution to a differential equation in this form can be found using partial fraction decomposition by first separating the variables. Separate the variables, integrate both sides. You'll have an integral that would require partial fraction decomposition. Or you could memorize that when the differential equation looks like this, the solution always comes out like this. P equals m over 1 plus a is some number you'd have to find, times e, we know what e is, to the negative m times k. You're going to multiply the 700 times this number here, 0.0008 in this case, and t is also part of this exponent. Negative mkt is the exponent on e. So if you can memorize this, then you could avoid the partial fraction decomposition. In this example, the solution to the differential equation is p equals, where the m is, we're going to put 700. Down below, denominator is going to be 1 plus a e to the negative mk. That means you have to multiply the 700 and the 0.008. But put a negative in front of that. So it's going to be negative 0.56 with a t multiplied, negative mk times t. Now you can't say that's the solution because you have this a in the answer. And we're going to find that a using the initial condition, which is P equals 10 when T equals 0. This is given. When T is 0, P is 10. I'm going to plug these in and do some algebra. Replace P with 10. Replace, we're doing this so we can find this A. E, we're going to find A. So it's A times E to the 0. Because when P is 10, P is 10 when T is 0. If we cross multiply here, we have this equation we can cross multiply. We can say 10 times this denominator equals 700, because under the 10 there's a 1. 700 times 1. A lot of ways to solve this. You can divide both sides by 10. 1 plus A equals 70. E to the 0 is 1. Divided both sides by 10. So A equals 69. That makes this the solution of the differential equation is exactly what's here, but with a 69 where the A is. So it's P equals 700 over 1 plus 69 times E to the negative 0.56t. Remember, we got the negative 0.56 because it's m times k. That's m, and that's k. That's it. So we really solved this differential equation without doing any integration, without doing separation of variables or integration. Integration would have required partial fraction decomposition. So now we're going to do number 24, and that will be it for this video. This is the answer to number 28. 24, going back to number 24. We have this differential equation, dp dt equals negative 0.0008 p times 700 minus p. It's the same differential equation as in exercise 28. But the different questions. The questions are: A, find the carrying capacity. And on the handout you have, you'll see that when a differential equation looks like this, the m is called the carrying capacity. You should look at a graph. You should look at the graph of this solution to see why that's called the carrying capacity. So in parentheses, m minus p, whatever m is, that's called the carrying capacity. Part B, the size of the population when it is growing the fastest. Here's a fact, it's on your handout. The population is growing fastest, this is in general. Anytime there's a differential equation that has the form of logistic growth, the population will be growing fastest when the population is half its carrying capacity. It's a general statement. In this case, the population is growing fastest when P is half its carrying capacity. So we're done with part B. The size of the population when it is growing the fastest. And part C, the rate at which the population is growing when it is growing the fastest. The differential equation is the rate. The rate at which the population is growing is given. And there's no negative here. I don't know why I have that negative sign there. There's no negative sign. The rate at which the population is growing is given. It's the differential equation. The rate at which p is changing is 0.008 p times 700 minus p. And our question is to find this rate, find the rate when it is growing the fastest. That means when p is 750. So the rate that they're asking for is going to be 0.0008 times 350 times 700 minus 350. That's the answer. That's the rate at which the population is growing when p is 350. In other words, I said when p is 350, that's when it is growing fastest. Point 0.0008 times 350 times 700 minus 350 is 98. So the units in all of the answers, A, we'd say 700 individuals, because it's a population. B is 350 individuals. That's the population at the time that the population is growing the fastest. And this 98 is a rate. P is the numerator, population, that's individuals. But it's a rate. The denominator is a T, so it's individuals per year. Because time is measured in years. In the directions, you'll see that. We're done.